Hi, welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life.
How you doing, Chris? You made it.
I did, yeah.
You had to rush from work.
You know, I was so angry today. I was thinking to myself, I know exactly what I'm going to talk about on the Amp Hour today. I was going to do a little dance, and I was going to be like, yeah, we conquered the time difference. I finally got it. I honestly thought that. And then, nope, nothing.
No, because we've been screwed again, haven't we?
Yep. Stupid.
Yeah, because once again, we were both thinking that because daylight saving, we've been an hour out of sync for the last, 4 or 5 episodes or something, and we thought, well, daylight saving ended at your end, but I thought it was just starting, and you thought my one had just ended instead of started or something like that, and now we're 2 hours apart.
Yep.
So, what do you do?
What a mess.
Anyway.
Yeah.
Bloody time zones. What can you do?
You know, I was thinking about switching over to GMT and just going by that all the time.
Right, just actually changing your actual watch to
seriously,
GMT and
But then I'd probably miss local appointments where I'd be like, oh yeah.
Exactly. You'd be screwed like, work and other things. Yep. Meeting the wife somewhere and
right.
Yep. Oh dear. Anyway, we have an action-packed. Action-packed? Well, and yes, a packed show today.
There's a lot of good. You know, I think we kind of both took it to heart last time that we didn't have enough tech stuff.
Yep.
You know?
So I think there's no shortage of that here today.
We're like oscillating back and forth. Now we're super nerdy, and then next time it'll have no content that's super nerdy, and then back and forth and back and forth.
Right.
Yeah.
Well, let's start with our usual shout-outs. We have a couple.
Yeah. I could put a couple on here.
You added them in here. Tell us about them.
First one was a new show by Troy Rank. He talked to me about it. It's about electronic bikes. So, there is the biking aspect to it, but in this case, he also talks about like power electronics. Like his first show, he was talking about someone that had 36 FETs in a power converter on the bike.
Nice.
So I think that's going to be part of his regular content is actual power electronics. So, welcome to him, and hopefully he does well.
Hope you do well, Troy.
Yeah.
And next we've got it's under shout-outs, but it's 555 timer.
I was looking at that today. Yeah, I put that in as a shout-out, but just like I was looking at it today because I saw a news article about someone making a new one. I forget who it was.
It was the original designer, Z-Tech came out with Z-Tech, who are now Diodes Inc., came out with a low voltage version of the...
Yeah, that's right. Yeah.
Yeah, 555. They got the original designer back in. I forget his name, but they got him back in to design a low voltage version. But I think that might have gone by the wayside now, but somebody else is doing another version,
yeah, I think someone else is doing it. Yeah, so anyway, I just wanted to shout out, how many designs out there? 40 years? That thing came out in 1970. That's intense.
Even before I was born. So there you go. That's how old it is.
Yeah, it's just beautiful design, not like the most power efficient or anything like that, but it gets the job done, and it's amazing. So I thought
absolutely.
I thought that was a shout out. I mean, people obviously talk about the 555 all the time, but how do you say it? Do you say 555?
No, we say the 555.
555, really? Okay.
555. It's always the 555. I've never heard about the 555.
No, you never
even
call
from
it that?
Yanks. No. It's always the 555.
Well,
the 555 timer. Yep.
Yeah, I guess.
You just don't have much street cred if you're going to call it the 555. I don't know. It might be big in Ohio. I don't know. Maybe.
Yeah. Us trendsetters in Ohio.
Right. But yeah, it's awesome. So a shout out to a Chip.
Of course.
There you go. Last I heard, probably only a couple of years ago, they were still selling over 1 billion per year.
Yeah.
Also, it's insane.
Yeah.
It's insane because they're still putting them into all those farting toys and stuff like that are coming out of China. So
and there's just so many
designs
that are out there that are just all these legacy designs that use them, and there's a lot of variants on them too. I know that like LT has these like modules that are supposed to replicate some of the functionality, but But even that, it's like, well, why bother when you can get them for like 10 cents? Why bother paying the dollar to LZ?
I think an expensive one is 10 cents because there's such a whole grey market built around the 555 timer as well. Every Tom, Dick, and Harry does a version of the 555, so very readily available. That's one part you'll never be stuck with. Oh, it's out of stock. Sorry, can't get it. You'll always be able to get the 555 somewhere.
Only if you're like really brand loyal,
right?
No,
exactly.
It has to be
I only
Z-Tex
touched the TI version.
Yeah.
Yeah. All right. What we got a whole stack of stuff. So let's start from the top.
Well, I had one more shout out.
One more shout out.
One more shout out. Yeah, sorry. I saw an article today about Google's interview questions.
Oh, yes. Okay.
And they were so that like usual interview questions. One was like how do you figure out how many golf balls would fit inside a school bus? Mind benders, blah blah blah. But the one that I wanted to give a shout out to is the fact that they ask what Deadbeef is. And
see, I had never heard of that because I'm not a software geek. So
you never heard of Deadbeef?
No, I haven't. I'm afraid not.
It's just
I'm not computer science geeky enough.
That's kind of on the edge though, because the thing is and that's what I wanted to talk about is the CS guys might not necessarily know what that is because software gets so abstracted these days. If you get a Java programmer, they're not going to necessarily know what that is. Some CS guys don't even know memory space kind of stuff. So I guess that's kind of like the computer engineering side of things. But
right. Yeah. No, I did mine 20 years ago almost, so back then it was like you worked at such a low level that you didn't have any of that sort of, I don't think Deadbeef was around 20 years ago, was it? I don't know. When does it date to? But it might even be before my time, I'm not sure, but it was always used on bigger systems like the Suns, the Solaris and all those big operating systems, whereas I always worked down at the extremely low level, set up, register A and set up register B and, this Deadbeef thing if you had Deadbeef in there, it's just pissing away 8 bytes or whatever, So...
no, that's a good point. I mean, but that is what it's for. I mean, we didn't really explain that, but Deadbeef is a check, so as you're looking down the memory and you see Deadbeef, it's a very recognizable thing and you just see it right away. And so... yeah, I mean that's understandable. That is a good bit of data you might not want in like really really small embedded systems. Yeah. But now it's kind of to the point where they're merging. Like even like the Arduinos and stuff like that. If you're looking at a memory register, right, and you want to see a recognizable character, you might throw that in there. If you're troubleshooting.
Okay, see, I wouldn't have used Deadbeef. I would use Hello World or something,
well, no, because it's hex too. That's the other thing.
It's hex. Yeah, that's the whole idea. Is the word Deadbeef can be? You can come up with a better word than Deadbeef out of hexadecimal characters.
There's feed beef. There's what else is there? There's dead. No, not dead. I'm sure there's a lot of good ones. If you have good ones, people can throw it in the comment section. But there's some good ones out there. Yeah, you only get A through F, so.
Yeah, I know. But surely there's better words than that. Anyway, I had never heard of it, so that was news to me. But yeah, I hate those Google interview questions. I've been to a couple of job interviews where they try and copy that Google technique of asking these Mensa type, the high IQ club. They're like these puzzle questions. And they're stupid, they have no relevance whatsoever. So
right.
Yeah,
well, and I think that's kind of the thing. They probably expect a certain level of skill to start with. Either from filtering, and then they want to get the super duper top people, but the people
who answer those Mensa questions aren't necessarily the people who are going to be the best at what you want them for.
Yeah,
so
I agree.
If I'm hiring a guy who has to do PCB layout or something, guy or girl, then I don't give a shit if they can answer Mensa questions. Geez, show me your boards.
Right.
Yeah, that's anyway. I don't like them. And there's a bit of a trend of companies doing that, asking these questions. It's all trendy to be like Google and Microsoft as well do the same thing. They're famous for doing that as well. So
well, they're going to start running into the problem too. Where either they're going to have to start making up their own riddles, or because these are basically what they are, or they're going to they'll get something new and blah blah blah.
Yeah,
I still like
the problem.
No, go ahead.
Sorry. Well, the problem is you don't know whether it's a trick question or whether or not there's a real smart-ass answer, or whether or not it's just they actually want a genuine answer, like how many golf balls in a they just want to see your process of calculating it. Whereas, you think, do they want the smart-ass answer?
Right. Yeah, can you imagine that you're in an interview and you're like, one golf ball can fit in
because it's a big freaking golf ball because you didn't define the size of the golf ball. Yeah,
Yeah, and then they just kick you out.
Yeah, exactly, because you're a smart-ass instead. Yeah, I know. That's why I don't like those questions. There's just so many ways to answer them.
I know.
So,
I've asked a question like that, and I think it was one of the few times I've done that, and then I just got like the deer in the headlight look, and I'm like, I felt really bad, and you feel really bad, and then you're like, oh, I guess I won't ask this anymore.
Exactly. Oh, dear.
Yeah.
All right. Well, we wanted to talk about lead drivers, didn't we?
Yes. Yeah, definitely. I saw your project starting up, and I'm doing a little bit of that too. So.
Oh, okay. Doing some lead driver stuff, huh?
Yeah. Are you doing?
Okay. Well, if anyone hasn't seen it, we can put up a link. I was doing a RGB LED driver thing at work. It was one of these, which we'll talk. Another thing we want to discuss is the crisis engineering.
Yeah.
So we'll get into that later. We'll keep it separate. But yeah, I've got these RGB modules. I was mucking around with these RGB modules the last week. I've been flat out on that, and I sort of caught the bug. I think I will do some RGB modules as a personal project because I reckon there's a because you can buy these full color RGB matrix modules from like SparkFun, but they're like $60. Well, I reckon I can easily do the equivalent or better for half that price.
Yeah.
So, I think I'll have a go at that to try and make some low cost RGB matrix modules.
Can you explain how so you buy the actual panels themselves? Is that correct?
You buy the RGB module, which has the matrix of the RGB LEDs in there, but there's no circuitry. They're just interconnected in the row column matrix thing. And then you've got to wrap some sort of driver around that. Usually it's a microcontroller with some shift registers or something like that. A lot of people do it with shift registers.
Okay.
And then that's because, I don't know, they don't want to use a big microcontroller, but I think a better way to do it is just to use a big-ass pin count microcontroller to drive the 24 RGB columns plus the 8 rows as well. So, yeah. There's many different ways. You can buy dedicated driver chips, but they're generally hard to get, so you want to avoid those from the likes of Maxim or whoever make these dedicated chips. And they're really nice, but they're like $8 a pop, and you can't buy them.
Yeah.
So,
yeah. Well, that's actually what I'm working. I'm designing with those because I'm doing a higher power situation. But I was going to ask you about those modules a little bit more. So explain to me the anode cathode. Like, what's the hookup of those? So you'd be driving an individual single LED with a micro pin then, with your idea?
Well, you basically can't drive. Well, you can drive a single LED, but you usually drive them as a column, as a row or a column, depending on how they're configured. So generally, you will output say 8 bits for the red. So you might drive a red column with 8 bits, and then you turn on that particular row. And then you switch to the next row and you multiplex the whole thing. There's actually, I'll put up there's a Agilent application note for driving RGB matrix modules, and it's quite detailed.
That'd be great.
Link. You'll have to remind me to link that one in. But it's not something that you can easily explain on radio. It's easy. It's much better just to show people a diagram of how it's wired internally. And but it's basically rows and columns, and you have to do a matrix it's totally multiplex driven, so you can't just drive an individual LED. So you got to do them row column based.
Okay, so
and it can get quite complex, especially if you want multicolors, because then you've got to do multiplexing and PWM at the same time.
Interesting.
So if you want the vari-colors, otherwise you just get the one fixed color, and you can mix red, green, and blue, and you can produce the however many colors it is from those. But if you want the graded intensity, you've got a PWM as well.
So are you throwing actual digital signals to the module, and then the module has its own internal drivers? Or are you actually pushing current?
These modules, which I don't. They're purely just a shift register-based thing, and it's all controlled via the one main CPU, which has to do everything. But as you'll eventually learn with these sort of things, if you've just got the one processor trying to drive 50 of these modules, it doesn't
it'll
work.
Brown out,
the bandwidth requirements are just so massive that you just can't do it. So...
I think that's where I'm
so
confused.
It's better to have a local CPU just dedicated to that one 8x8 LED matrix, and then the CPUs talk to each other and share the data and all that sort of stuff. So,
see, I guess that's where I'm confused, because I'm not sure. So you're not driving though the individual LEDs with the current output of the micro, are you?
Well, you're actually driving them with the current output from the shift register.
Okay, yeah.
Well, I'm not doing that in this particular design, but the design I'll do personally, I think I will actually do that. I will drive it directly with the microcontroller, because you only have to turn like 8 on at once, and if you got 30 milliamps per LED, that's probably just inside the maximum total pin current specification of the micro.
Yeah.
So you can actually drive them directly from the micro or from the 74HC 595 driver or something like that. So,
okay. Yeah, that makes sense then. Yeah, that's a cool idea. I kind of like that.
Yep. And then they're multiplex, so the average current goes down, and so you aren't actually exceeding the total average current consumption for the
I think the interesting...
Because if you're not aware, well, you are, but the viewers out there might not be aware that chips, including microcontrollers and 74HC devices, they will have two specs for output current for each. They'll have an individual spec for just the one pin. It might say you can't draw more than 30 milliamps maximum from this one pin, which is great. You think, I can drive a LED directly with that. But then they'll also have an additional specification on top of that, which says you cannot exceed a maximum of 200 milliamps on the ground pin or the power pin. So while you can drive, you might have a 100-pin microcontroller, but you can't get 30 milliamps out of each one of those pins because you'll exceed the maximum ground or power pin current. So
and that's usually package limited or
and that's usually limited by the package and the bond wire going over from the one power pin you're using or something like that. So
that'll be an interesting trade-off, because I'm guessing you're going to have to go with a really small micro to try and get your costs down. Well, not that small, I guess, but
it's physically a small module too. So I need a small. Yeah, it might be I might even have to use the dreaded, flip chip or BGA or something like that. Ooh,
God.
God help me.
See, I don't think that would get cheap, though. That would start getting expensive, I think.
No, they're very cheap packages. If they're generally cheaper than the DIP and the QF key, because they don't have to put the bond wires in then, because the ball is directly on the back side of it's on the substrate or something. I think it's a cheaper manufacturing process. Don't quote me on that, but I think that's one of the advantages of those Chipscale packages and the BGA is that they're physically less work to actually manufacture the actual package.
Oh, okay. So I had thought that they were. I mean, DIP is one thing, but I didn't think QFP was that much more. So.
Right, but that's the same thing because you have an individual bond wire, so you've got to have the little robot arm that comes down and welds on each little bond wire from the pad to the pin and stuff like it's fast. The robot arm comes in, but hey, if it takes an extra second, well, you add that up over time, and you can only get 10,000 chips a day instead of 100,000. So it all adds up.
That's good, man. That's real good.
Anyway, enough about LEDs.
Yeah. Woo. Well, no, it's that's really good.
Okay, what else have we got? Next up. Oh well, you wanted to rant about the size of packages.
Oh
go for it.
Yeah. Well, I mean, I was actually, I'm actually running out of room. I mean, that's a personal problem, running out of room on a computer now. But the, because my hard drive is only so big. But I was going through uninstalling everything, and the. I'm starting to see these packages being like 3 to 4 gigabytes, sorry, I thought you were talking about chip packages, but you're not. You're talking about the software development packages. Yes, yeah. So like FPGAs.
Yes.
I mean, FPGAs are usually a little bit worse, but even like I was doing micro stuff for Freescale chips, and just these huge because they have to pull everything in, and I don't get why they're not like on demand kind of applications. Like why isn't it like, okay, I'm using an Atmel 328 whatever, like, okay, now I go to the web, I get all the latest software, and then I pull that down instead of pulling down, there's like this archaic system where they pull every single chip that's available, every board support package all in at the same time, I have to wait because I have a slow internet connection to get all down, then install it. It takes up, some decent percentage of my computer, and then I'm screwed. Like I start running out of room, and I have to actually uninstall then. So it's ridiculous. Yep. I don't know.
Well, first of all, you've got to step into the year 2000 and get a decent size hard drive and internet connection. But
that's,
I know what you mean, and I work at a company that does this sort of thing, and it's all one package. You have no real option. You download the whole
thing.
Yeah. And I don't quote me on this, but I believe it's done because it's just easier to develop. It's easier to keep track of. It's easier to, when you generate the build every day, when you're in the software development process. I'm not geeky enough to understand it all, but basically they build packages every day, and if you keep everything separate as, you've got 100 different things you can download, I think that's harder to manage from a software development point of view. So I think there's reasons why all these companies do it as one big build is the actual industry term for that.
Right.
A build.
I know.
Yeah,
I'm sure there are some real reasons there, but it's still, it's enough for me to get angry because, I understand the hard drive argument that's out of my control, unfortunately. But even aside from that, like, these, I think they're very unwieldy. You know what I mean? And
Yep.
I don't want to knock them too much because they let me make stuff. But come on, man.
Yeah, I know. Well, it's the same thing with the EDA packages. Now, all I want to do is a schematic and PCB, but what I've got to install 3D, FPGA, micros, drivers, 10 million different libraries, and God, I just want to lay out a 555 timer on a board.
I know. Yeah. That actually, did you? So you had posted a thing about the Amanda Wozniak's video about hardware will cut you. Did you get that quote in there? If you think Microsoft is bad, you haven't touched Cadence.
Oh yes, I saw that. That was
I thought that was awesome.
That was good. Yeah, actually, we should talk about that now that it was something I wanted to discuss. I posted it on my blog because I thought it was kind of interesting and people, might learn something from it. This cool chick, Amanda Wozniak, no relation to the Steve Woz.
Right, she says that up front.
Yeah, she says that up front. Yeah, she gets sick of, are you Steve Wozniak's sister or something? No, daughter, no. Don't know him from a bar of soap. And she did this video presentation at DEF CON or one of those hacker conventions.
Yeah.
I'm not sure which one it was. And it's called Hardware Will Cut You. And it was a 20-minute... Yeah, cut you, bitch.
Cut you.
And it was a 20-minute rant. And it was quite good. It was like a PowerPoint slide, extremely fast paced. She talks even faster than I do, which is bloody incredible. And she, it was interesting comparing the hardware design process to the software development process or something like that. And it was more targeted towards software people who wanted to get into doing Arduino stuff and encouraging them to get in. But a lot of people commented that she was too crass and condescending, and there's lots of swear words in there, more than me. She does drop the F-bomb a couple of times, which I try and avoid. I really do my best to cut the F-bomb out of this show and the live shows.
Well, that's good.
So, but she was, really full on. And I thought it was kind of fun, but
I didn't
a lot
think
of
it was
people
that
took
bad.
offense.
I don't know.
Well,
I got to hear Lamore talk at the Open Hardware Summit. I thought, very similar to that. It was just like she's just BSing with her friends. Like I don't get what the problem is. And I think, other people were saying that, she's talking down to people. Whatever. I think she just knows what she's doing. she sounded legit to me. She definitely knows the hardware process. She's experienced it.
Yeah.
And she was showing that she was kind of pissed about it.
Well, she kind of had. Everyone said, she's got an axe to grind against, but
Whatever.
No, I think she just didn't want people to, her things are genuine. She didn't want people to experience the same crap she went through during the hardware development process, and she just... speaks a mind, I guess.
Yeah, I really like. I like the content a lot. I thought it was very, to the point. It was concise for the development process. So all of that stuff was good, and definitely my favorite my favorite analogy she made was when she was talking about, software versus hardware. She's like, software, you can make stuff at your desk, you can do a build from scratch or whatever, and you can do it in a day, whatever. And she explains that would be like writing a program, sending it on your grandmother on index cards or something like that, and then a knit is a 0 and a purl is a 1, and then later
purl is a 1, and then please knit me this program. Yes,
it's brilliant,
and it takes you a month. Yeah,
that's a great analogy.
That's very good.
Yeah,
there was some good stuff in there if you get past the swearing and everything else. So
yeah,
maybe. I don't know, but a lot of people seem to take offence to it. Well, each to their own. As I've learned, you can't even please a minority of people. So don't even try. Just do what you want to do and be yourself. Basically,
maybe one time we should have an episode of the Amp Hour where it's all like sweet and then you play some resistor. And, don't worry if it blows up. And
bullshit to that.
Yeah, right. Screw that.
Yeah.
Yeah. So I liked it. I'm glad you put. Where did you find that? Did you see that on Adafruit, or where did you?
No, somebody posted on my forum, but apparently it was on Adafruit and all the other blogs as well. Apparently, I'm a week late, so
yeah.
Because I don't have enough time to follow all these blogs.
I feel like lately I could just follow Adafruit because they've been getting up a lot of content lately. So it's them and Make. I've been following them, and actually I posted something about those two. I just saw it recently, just today. They're having a design contest. Do you see that?
Yes.
Buy, break, and build, or I guess buy, break, build, and it's actually going to be hosted on Hackaday. And then it's sponsored by Adafruit and Make. Adafruit is supplying the prizes, and I think Make might be as well. Yeah. And basically what you do, it looks awesome. You take one of those dancing Santas, it's like playing Jingle Bell Rock.
Great.
Yeah, those little, they got like motors inside, super cheap stuff, a little tiny control chip, whatever. And so someone's going to be circuit bending on that kind of thing, and someone else will drive something else. But they have different prizes based on what you take out of the Santa and then make into something else. So I think it's a really cool idea.
It's very cool. Just don't get too excited over the prizes, kiddies. I think it's like a Minty Boost or something like that.
It's for the fun.
It's not major.
No.
But Adafruit have another major design contest, which I think somebody's close to winning, which is $2,000 first prize.
Oh, the Connect
for
prize.
anyone who can tear down. Anyone who can release open source drivers for the new Microsoft.
Yeah.
I can't pronounce it. I forget how to pronounce it. The little 3D eye the Connect, or something
Connect.
like that, with a K.
Yeah, with a K-I-N.
K-I-N Connect. Yeah, fancy spelling. Yeah, I think someone's very close to doing that now.
Yeah.
I just had a fleeting thought yesterday after I saw that. I thought, well, I hope Microsoft doesn't sue them, because here they are encouraging people to giving prize money for people to break their technology. Basically, so I don't know.
They were talking about. I was listening to Ask an Engineer yesterday, which is their Saturday program, and they were talking about, and they make a really good point. Phil Terone was talking about. He said, there is nothing against. You're allowed to do whatever you want. It's your piece of equipment. You know what I mean? You're allowed to do that. So. More power to people.
Lawsuits. Well, no, I think there's a recent lawsuit which I might have been here in Australia, but it has implications anywhere in the world. It basically against these game console modding chips, right? And basically the mod people lost. The court said, no, basically you don't have the right to mod that console to get around the actual software protection built into that console. You don't have that right. And it was made big news several months back. So, I don't know. The lines are still blurred on that, I think. So,
well, I
don't
will say my
underestimate the power of
here.
The blood-sucking lawyers. So.
I was going to say, I think that's a load of crap. I think that,
totally.
if I'm paying money,
but,
if I'm paying money for something, I'm allowed to smash it into a brick wall if I want to, and I'm allowed to open it up, and I'm allowed to use it however I want to. Now, if you want to hit me later, if I'm doing modding, and then I go and download an illegal game, and then I use it for, and that's why I need the modding. Then the illegal act there is the downloading of an illegal game.
Well, I think you're allowed to personally do it in your own home, but as soon as you distribute the information, then you become liable or something like that. That's whole idea behind
that's...
this mod lawsuit, which the game, I think Sony bought it in. Sony started suing all the people selling these mod chips, and basically you didn't have a right to sell this mod chip, I think was the end result.
See, now that's different though too, because you're selling a product. If you're selling a product where you actually are selling like if you sell a radar jammer, right? I think that's the same kind of thing, right? So you sell a radar jammer. Yep. Yeah, it's illegal, right, to sell them. But if I go out and I make a radar jammer, that's all on me. You know what I mean? So I think it's the fact that they're selling a chip that's the part that's illegal, not that people are doing it. So
I think so. But from what I read, the lawsuit, the judge said that basically, no, you don't have the right to do it. To your console. I think that was the big uproar over that.
Okay,
anyway, let's not harp on that.
That's not really our domain.
It's bullshit. I know.
Right.
So
I think it's great they're doing it though. Have you seen
it's great.
Have you seen the thing in action? The games?
No, I haven't. No.
I saw it.
But they can track your movement in real time. 3D,
yeah, it's really cool.
So you don't need a hand controller anymore. You just wave your hands around.
Yeah, it's really great. Yeah. I think it's a great idea. So
awesome.
Yeah.
And I think some guy's very close. I saw some video of him, there's like this figure, and he pulled out the video, and he was actually, he stood in front of the camera, and it tracked his hands and his feet, and awesome work. So, and it was within a day of them posting up the contest or something. This guy had done it.
Yep.
It was like crazy.
Yeah, that's great.
Oh dear. And we have a discussion point now. Where do we draw the line between scientist and engineer? You added this one. Go for it.
Well, I was hoping you would answer that, Dave.
Oh, right. I was right.
No,
well,
I mean, I have thoughts about it, but I don't know. Like, I think about it like on. So your favorite show, right? The Big Bang Theory, right? The one guy is a engineer, but they're all nerds, right? And what is that line really? I mean, the fact that he's and even in schools, a lot of times that line is blurred. There's people getting a PhD in engineering. Well, what's the difference between that and a PhD in science? You know what I mean? I know there are actual differences, but...
Well, I always make the difference that, science and scientists are at the academic level, so to speak. They can be at the practical level in there's you're a scientist, you're producing drugs, but I sort of more associate science with the... you know what I mean?
Actual drugs,
drugs.
Only
like
drugs.
If you're
a scientist. You're making drugs. That's it.
You're making drugs. That's it. Well, but I see it as the scientist is more academic. They do theory research, and the engineer does practical implementation side of things. I know it's totally. They're all totally blurred, but that's generally how I see it.
Right? Yeah, but I mean, like, there's.
I
think about
right?
it. Yeah, I think that's a great explanation, but I think then, I think about people I know that are doing PhDs, right? And basically, they're doing a PhD in mechanical engineering or electrical engineering, and at the end of the day, they're basically they're scientists, you know what I mean? Like, they don't call it that because they're focusing on a certain discipline, but it's what's the difference really? You're getting grant money, you're going out, you're forming hypotheses, you're testing hypotheses, and maybe the difference is you're making something in order to test them versus, doing theoretical.
Well, that's the thing. As a scientist, you're more working, or as a PhD researcher, be it engineering or science, you're working more at the fundamental physics level, or at the a more fundamental level than engineering is a higher, more abstract system level thing.
That's true.
Take the stuff that the scientists actually produce and you do something practical with it. That's I don't know. The lines are too blurred. We probably shouldn't even talk about it, really, because we're just ultimately going to be wrong in some way, shape, or form. So
yeah. Well, I mean, I had MythBusters as an example, right? So I mean, those guys they say they're doing science, but like those guys are making stuff every day. Like they're testing out hypotheses by making cement trucks blow up.
To me, that's engineering.
Right?
It's using scientific principles, but it's not science. It's
scientific method.
They're doing junkyard engineering, just cool backyard engineering.
Yeah. So I don't know. It doesn't matter really. I thought it was an interesting.
No,
I didn't even remember when I wrote that. I was just thinking about it, and
Right, and it popped on the list, huh?
Yeah, it got on the list. I was thinking so many tech subjects last week. I was like, I got to get something.
Yeah, because the list was looking a bit slim there for a while.
It was last week, yeah.
Oh, dear.
Well, speaking of engineering, let's hear about your Scramble. I mean, you were talking about that earlier with the LED boards, but, I mean, if you were an engineer, I'm sure scientists do it too, no disrespect, but, if you're an engineer, you've probably had the 11th hour Scramble.
You probably have. It's happened without fail at every company I've ever worked at, even on my own projects as well. Not so much because, I can go, I don't give a shit, I'll do it tomorrow. But the 11th hour design scramble where, in my case this week, I had to make a deadline for a trade show. So it's a fixed deadline. You have to produce this product. It has to be, there at 10 a.m. on the trade show stand. Wham, that's it. There are no, it's either all or nothing. You have to do it.
Yeah.
And for somehow, we always seem to do it, and in this case of the RGB boards, which had to be at this trade show, and I want to know how we're able to do this. Are engineers more productive under extreme pressure? I think they are.
Oh, yeah. I
had a week to produce this board from nothing. It was, basically we had to produce it, populate them. We had to build 20 of them by hand because, we only had like 10 days or something. So we couldn't send it out to be contract manufactured because it takes 5 or 10 days just to arrange that, let alone do it. So we had to build 20 of these boards in-house. We had to get design the PCB, lay it out, get it manufactured overnight in Taiwan because we couldn't find a local manufacturer who would do it quick enough.
Wow.
Because it's all, if you've done the Gantt charts and you know that, well, you can't build the board unless you physically have it. So, that process has to come after the timeline of building, getting the board manufactured, and then you've got delivery. How long does it take to, get here from Taiwan? And we did it with time to spare in the end. So, I don't know. It's just crazy.
Well, then, if you did it with time to spare, how is it 11th hour? I don't get that. I mean, you just mean like short timeline?
Oh, well, it's just a short timeline. I mean, I've done ones where I've actually been on the trade show stand, actually hooking stuff up, getting ready. People are walking through the door, and we're literally finishing it with minutes to spare.
Don't look.
Yeah, it's like we're hoping that it'll take people time to get through the doors and get to the other side of the hall before we're actually finished this thing.
You always bring the basket of emergency muffins to distract them. You're like, and we have muffins over here.
That's what the hot chicks are for in the hot pants. You see, they'll gravitate towards those stands first before they get to you. And that's how. That's how 11th hour it could be.
You actually hire the hot ladies for other stands, so they'll actually stay away from yours when you
exactly. They'll stay away so we can screw everything together and get it bloody well working. I don't know, but it happens. Every company does this, be it for a trade show or something else. They just put in these ridiculous deadlines. You must be finished by this day. And but if we couldn't get that PCB manufacturer to manufacture that board within 24 hours for us and ship it out, we were screwed.
Yeah.
The whole thing, true. I probably would have had to resort to making those boards by hand, and they would have looked shit. They would have been a crap, and they wouldn't have even been a tin plate thing. I could have run solder over all the tracks to tin plate it maybe, but it would have been really crap looking, and
it would have been like Sharpie etched and everything.
And if any one of those little processes didn't come in, if we couldn't get the parts in time or whatever, then you're screwed. But somehow it all always seems to work. You always seem to find a way. And
man, that's pretty good. I mean, I guess the there's two things that, I think the one thing that allows it to work more often than not is the global marketplace. In that case, I mean, the fact that you can get it fabbed in Taiwan overnight, that's kind of ridiculous.
it's pretty, I know.
I don't know about awesome. 20, 30 years ago. I don't know if that would have happened just because you would have had to find a local guy, then you would have had to squeeze it in, or I mean, you probably still paid through the nose for that, right? I mean, that's usually the trade-off too.
Yes, we paid big money for those blank boards, So
I mean,
it's crazy. But
I think the global marketplace
comes down. I think it's that, and I think a good engineer is capable of just doing the timelines in their head, knowing that I know we have to push the button today on that board to get it in time, and you just know how long things instinctively take. And,
that's an experience
thing. It just all comes together, and you know where the key points are. Like, if we don't get this board, well, the whole thing's off. So you focus your energy on getting that board, and then you know, okay, the parts are relatively easy to get, and if we can't get them, I can find substitutes and all that sort of stuff. So, or we can make do, or we can salvage parts off old boards, or we can, So the parts might not be as important as the bare board, for example. So you know where your priorities lie and that sort of thing. So, but it all seems to happen. And you don't do Gantt charts for this thing, and you don't have meetings. You don't sit down in a meeting and do a Gantt chart of, okay, we need this board by this. Some companies do that, but geez, you spend more time doing that than actually making it happen. So
I've actually studied some of this stuff before.
Okay, right.
So, like you were asking about, like, why does it always work and why doesn't this happen on regular projects, right?
Yep.
And so, and I mean, it's been out there before, but it's been out there for a long time, but like just the iterative design model, there's actually like a whole ton of stuff about that now. And I've been studying some of that stuff with my coworkers about, like, basically you try and time box yourself. So like, instead of saying, so like, say you have a project
time box, there's a wank word. Yeah. Time box yourself. Sorry, I haven't heard that one before. That's quite novel.
You might hear it in the near future. Who knows?
Right, okay.
The Chris Gamble management method from a guy who's not a manager. Yeah.
Green belt.
Oh, God, yeah.
I know.
But the idea is, it's very very intuitive once you start learning about it. But like, you think about like a project, right? So you go out, Dave, and you say, okay, I'm going to make a an RGB module, but it's going to be 20 meters by 20 meters. That's right. I put that in metric for you. Okay. So it's going to be huge, and you need to figure out how to do that. Right. And so you have, you together with your whole team, and you say, all right, we have a year to do this. Right. And at the beginning of it, the first thing you're going to start doing is what's that? Besides, figuring out your project plan.
Oh, you figure out the system, how the system's going to work.
No, that's not true.
I get straight into the engineering.
That's wrong.
That's right for me.
That's wrong.
Nah.
No, you know what you're going to do at the beginning? You're going to do nothing. You're going to do nothing because it's a year away. You know what I mean? So
I was about to say that because you put in, like, it's a year. The last thing you should do is say, we've got a year to do this, guys.
Exactly,
you should say, we've got till the end of the month. And then
so that's kind of the whole idea.
And you become more productive. Well,
right, and that's the same idea here. I mean, you're productive because there's like a very well-defined date, right? And so this whole system I was studying was like, you start pushing in those dates to like 2-week increments or something like that. And then, at the end of 2 weeks, you have to have something done. And maybe you don't, I mean, either you're self-motivated or, you got to, show it in front of some other people or something like that. But there's a very definite date. And there's actually like studies out there about like how that can actually push together projects a lot more efficiently and, like predictably.
Yep.
So I don't know. I thought that was cool.
Then it becomes organized chaos if you try and, if the dates are too small, if they're too compacted, if your time box is actually too small, then it just becomes chaos and engineers go crazy and.
I think 2 weeks is okay.
Fist fights in the corridors, and there's people
every day would
be
tough, right? Because then it'd be like,
exactly. You got to have something done by the end of the day.
Yeah, 3:00. Got to go show my manager what I did. That would be like preschool, right?
That's called micromanagement. Yeah, and it's a pain in the ass, and it pisses every engineer off. No engineer likes to be micromanaged.
No, definitely not.
Yeah.
I agree.
No.
And if they do, they're probably not doing it right.
Yeah, exactly.
Yeah, but I mean, I think it's just kind of getting to that, like, kind of pushing yourself for a very fixed deadline. And I won't say the T word again. I promise. That the wank word, as you said. But I think it's a cool idea. I mean, and stuff I've seen that kind of verifies that it works. So, and I mean, I've done it myself too, so I like it.
Yeah. And it does work, and engineers are more productive under pressure. Otherwise, I think we're probably inherently a bit lazy, because we'll actually do the fun stuff, and then you won't want to do the hard work, because you want to continue to do the fun stuff. So, you'll just all that hard work you'll actually put off.
Right? Yeah. I mean, it's like, so say you're going out to make a board, right? And I want to talk about boards today too. But what's the fun part there? You want to go out and you want to just go start doing layout. You want to put down some parts and start doing layout and get it done and get a board and start building it. You don't want to go do part research, and you don't want to go figure out the most cost-effective option or anything like that. You just want to do it and get it done. But sometimes you actually have to do that other stuff.
Yeah, because the most important thing might be the cost of the board. That might be your number one requirement.
Yeah.
So
and these days it seems to be.
Oh, great! I've got to spend a month researching parts. Great.
Yeah.
And then by the time you finish that, they're all out of date and you can't get them anymore.
Yeah. I was complaining about that this week too on Twitter about the costs of small volume boards, and I'm making this board that's probably like 2.5 square inches, and it's so expensive. Like hundreds of dollars a board.
Rubbish. Go to PCB Card. It's $50.
Yeah,
Who are you using for that sort of price?
That was Sunstone. I don't know. Sunstone was pretty good.
Yes. No.
How many layers do you get though?
No, they're fairly expensive. Go to PCB Cart and a board that's only 2 inches by 2 inches. It'll cost you. Is it like a 4-layer, 2-layer? How many layers?
4-layer with I need solder mask and
Yep. Well, that's obvious. A 4-layer board will be $60 tooling cost, I think, plus maybe $10 each for the board.
Now you're making me look. How fast does that go though? That's the other thing.
No, that's a 12-day turn for a 4-layer board.
They
will do 8 days for, exactly.
Yeah, so
whereas the same board, if you want it one day in Taiwan like we got, it's $1,000.
Yeah, I mean, that's, exactly. And that's always the trade-off. I wanted a 2-day turn, and like that, that kind of stuff gets up there fast. Okay. I mean, like, I don't know. I like it. I like the fastness of it, but man, you really got to pay for it. So. I mean, if you really have the time, you can go to, like me and Jeff talked about with Lane, the pcb.lane.org. We talked about that, and he bundles the designs together, and that's going to take months. But I mean, if you got the time, I think it was $7 a board or something like that. So that's great.
I know. Well, actually, this isn't on the. This brings me into a point. I did have it on the list. Free samples. I just wanted to do I was going to do a drive time rant on it this morning, actually. I most likely will, but...
All right,
yeah,
preview.
I mean, everyone craps on about free samples now, and I used to use free samples extensively back in the day with Maxim and other companies that do great free samples, but there's lots of negative reasons not to get free samples. One, it generally takes a fair amount of time. You won't get your parts... you won't get them within a day or two, which is what you want.
I don't know, man. I get some pretty fast parts.
But it's not as fast as getting it from Farnell's. Maybe it's different in Australia, and often to get the samples, you might have to go through a local distributor or something. Once again, this might be an Australian thing. You go through a local distributor and they want to know all your details. They want to know what project you're working on, how many you're going to do, and all that sort of shit. And it's like, and they phone you up, later, can we help you? And oh God, I just wanted 2 chips.
That
leave
does
me
happen.
Alone.
You know why that happens though, is because they got to tie it back. And I mean, that's like the whole, like the sales versus engineering thing, right? Like they want to funnel people and blah, blah, blah. And it's like, we just want parts.
Your buddy and, I know, exactly. And the other thing is, you may get free samples, great, but can you get them when you go into production? That's the thing. So, I know people who design everything using free samples, entire board, and they build their one board. Great, look, it didn't cost me anything, or it cost me very little. But they're all free, and they will go, okay, we now have to make 100 of these. Oops, no, I can't get any of those chips because, they were some obscure part that they got for free.
Yeah, so you'll say you'd rather go to like a DigiKey or
I'd rather go DigiKey
Farnell.
Mouse. Well, Farnell's in Australia. You can order one single resistor that costs a cent, and they'll deliver it to you for free.
Nice.
So there's no advantage. If you want a chip, I can have it same day for $1 from Farnell's rather than going through all that rubbish to try and get a free sample from the manufacturer. It could take a week or more.
You know
with
what
all
you
the
should
crap
do?
That goes along with it.
Next time Farnell pisses you off with their credit card policy, you should put in 4 different single resistor orders in a day and keep doing that until they respond. Why did we spend $800 on shipping resistors to Dave Jones? I don't get it.
Exactly.
Oh, he was angry. Sorry.
Yep. Yes. Anyway, they actually apologised. I got a phone call from the head honcho, and they apologised about it all. And they fixed. Well, they said they'd fix it last time, but so I take that with a grain of salt. Anyway,
I like your idea though about the. Sometimes you just gotta that kind of theme pops up over and over again. You got to pay for quality. In this case, you got to pay for just the assurance,
hassles, or just the assurance that you're going to have the parts.
Exactly. And that makes sense, especially if you have like the system set up to get it really quickly. Now, if you have to go through a whole process to get a part. That's a little different. But
well, some companies I've worked at, to buy that one resistor from Farnell's, you've got to go and raise a purchase order and get it signed by three different people, and it's all got to be in triplicate, and then it becomes stupid, right? But now, I've got my own company credit card. I just whack it in, and the part's on my desk within, a day or less. So
that's great. That's really great.
Yeah. So, well, that's the other thing. An engineer can be so productive. Companies out there, if your design engineers don't have a credit card, well, bloody well, give them one. They'll be 10 times more productive. I guarantee it.
I love that idea. I was trying to pitch that to my company, and they didn't. They weren't going for it. I think sometimes it's an accounting thing too, but like
it is. But you've got to trust your engineers. I mean,
and that's another management. I don't know why the hell I'm looking at so much management stuff. I'm not going towards management, but like that's another thing. That's another thing they talk about though. Like you push it, and that's a Toyota thing, right? You push your stuff down as far as you can down the chain. If you have a guy that's turning a wrench and he needs another wrench, he should be able to go get another wrench. If he has to go talk to the VP in order to get a wrench, you're never going to get anything done. So,
but that's how it is in some big companies. A lot of big companies.
Yeah.
Most engineering companies I've worked at work with that big company mentality. You have to be accountable for every last cent, and it's just stupid.
Yeah, and if there's any managers listening to this, I don't know if there are. That's the thing. I don't know if any of our listeners are managers. But if you are, and you don't want to let us know who you are, just let us know in the comments that you're listening as a manager, because I'd be interested in that. You don't have to say who you really are. Don't troll us, please. Don't pretend you're a manager. But if you really are a manager, I'm interested in that, because I don't know who listens. I mean, we have some people that listen, or we know some people who listen because of that survey, but I don't know. So
managers. I'm just assuming not. Because managers don't give a shit about practical engineering or
that's not
shows
right.
like this or blogs, or they don't. Because they're professional. I don't know a single manager who's actually like a real manager, as opposed to just a token manager who's actually a real engineer. But a real, a manager's manager. He's got his MBA and everything else. I don't know a single one that actually goes out and actually takes an active interest in electronics and engineering. Outside of work is management to them. It's not engineering and technology. It's
really. I
don't know any of them.
I know at least one manager who's very active on the side. He makes his own boards and stuff. Yeah, I don't know. I think it happens. So
I'm sure it does, but I think it's fairly rare. It's more the exception than the rule. That's for sure.
Yeah, but I think anyway. once you start getting up into this, I never really knew what management was when I was getting started and stuff. Yeah. But I realized it's a lot of because they take care of projects and they kind of make sure things are going right, and if people need help, and they always say
that's what they're supposed to do. They don't always do that.
Well, okay, yeah. Okay, so best case, but I mean they always you ask a manager what they do, and they say, oh well, I remove barriers. I've heard that a couple times before, right?
Yeah, right.
And then so whatever that is, right? But what it really is usually is budgeting. You got to figure out where's money's going, and like that
time and people. You have to budget people as well.
People are money though too, because people translate to money. So I think a lot of times that's usually what ends up management's being. You kind of just making sure that the numbers add up. So I don't envy
money,
them.
and resources—they're the three keys to management.
Yep. I don't envy them, not at all.
No, it's a shit job. Anyway. Just give them credit cards, chaos, and we're much more productive.
Exactly right.
It's easy. You don't have to do anything as a manager.
The chaos model.
Give us the freedom to do shit, and we'll do it. So it works every time.
Just hire Dave. It works out great. Don't worry. Right. Just hire Dave.
And I'm just going to tell you you're a dickhead and you add no value to the company as a manager, so you may as well not exist.
That's not good.
Exactly. Hey. Oh dear. Yeah. No, I know.
So I want to talk about. I wanted to ask you about some layout stuff before we end, because.
Oh right, okay. How much time we got left?
think 5, 6 minutes.
5 minutes. Let's go. All right.
So you've been doing layout for a long time.
No, I've been doing layout for 20 years more.
Long time.
I used to be a full-time PCB designer. Yep.
Yeah. And, I've done a couple boards, not a lot, but like, where do you start when you start a board? I mean, I don't know. I know you've done some EEV blog stuff on this, but like, mostly I'm always kind of, and I was talking with, I forget who it was, someone on Twitter about ripping up boards and stuff like that, and how you have to always start over and just planning and stuff like that. And and the planning, it seems like that's just like the most critical thing that always gets skipped. So where do you start?
It is the most critical. Where do I start? Well, you've got to, step number one is to ensure you have a proper schematic and it's finished and it's got the design notes on there that you want, like, oh, this pin must be star grounded over to here and stuff like that. You've got to plan all that stuff, and it's got to be on the schematic, and then you have to ensure that you have all your footprints right, and you have your, all your library components are correct, and then you dump it. Once all that's, you might spend a month doing that.
Yeah.
But if that's correct, that's probably, a good half of your work done, and then you dump the components onto the PCB and you group them. That's the other thing. You don't just start. You don't try and place all the parts at once. You do little subgroups. Okay, I've got an amplifier. Well, it's an op amp with a bunch of passive components around it. You group those together. You route those in a little block, and you do everything building block style, and then you move the blocks together and. But it's... Man,
that's the boring part too, isn't it? I mean, like, not the blocking, but the upfront stuff, that just sucks,
Well, Ed, the old adage is that designing a PCB is 90% placement. Yeah. If you've got good component placement, the routing, is easy, almost,
right, because then you don't have to do all the super jump through 4 layers and scoop it back up. And
you don't have to run signals from one corner of the board to the other and stuff like that, because you laid it out and modular and,
right.
Same
I like the
with
modular,
your schematics as well. Your schematics are supposed to be organized logically, so the signals flow usually from left to right. Some people might do it from, or because if you do it the Bob Pease style, I don't know if you've seen Bob Pease's schematics, they go left, right, up, down, diagonal. They're all over the shop, They're his hand-drawn schematics, and they're a mess. They're not. They don't have a logical flow or a logical block separation to them. So
I haven't seen them, but I've seen similar schematics before, and those are just like, because you're so used to it too, and then you start seeing like signals coming in from all over the place, and you just start scratching your head like, I don't know what's going on here. But my friend actually has a really good technique for that, actually, where he takes highlighters of different colors. And he tries to separate all the signal lines and the power lines and the grounds. And then when you look at it, as long as you're not colorblind, apologies to those who are, you have a really like block view. Like you don't think that a signal line is now a power line. So that's actually kind of a fun tip for people if they have a lot of highlighters laying around.
Well, that's the old way to do it. A lot of the days, the EDA tools you're using will take care of that for you. They have a modular bus approach, and you can do lots of graphical stuff on there, so you can draw boxes around things, and
the analog
paper,
analog, very analog.
No, analog, right? Yeah, on the back of a napkin.
I mean, I deal with schematics that are like old, man. I've seen stuff that's in some old CAD packages that don't even exist anymore, and that just gets messy.
Yeah. But PCB design and layout is an art. It really is. It's not something that you can easily teach. Experience will ultimately teach you the most efficient way to do it. But the old adage again, if you give the same design to 20 different designers, they'll give you 20 different layouts. There's no one right way to do it.
That's good.
Every layout's going to be different. They'll place the parts differently. They'll route it differently. They'll have different thought processes.
Yeah.
Oh, I couldn't even start to.
Don't want to get started on
discuss it, but I might try and do. Everyone always asks for that. Do a blog on how I lay out boards properly, and geez.
Yeah, I mean, it's almost to the point where
it's like trying to teach painting. How do you?
Yeah, that's a good analogy, actually.
Yeah.
Okay, how
about
this?
How do you teach it? I don't know.
Do you know who Bob Ross is? Do you know
Bob
who that
Ross?
is?
No, never heard of him.
He was on the public broadcasting in the U.S. and he had this huge afro, and he had the softest voice. And over here next to the mountain, happy trees. We're going to have some little happy trees. So, Dave, if you could find some videos and do that for next year at Halloween, that would be the funniest thing I'd ever seen, I think.
Right.
Happy trees. Happy resistor trees. Happy ground trees.
No, that's too
come on. It would
happiness
be
and airy
so
fairy
great.
for me. No,
No.
no.
It's so great. I used to watch that when I was a kid. It would be like, I'd be homesick and I'd be watching that on PBS in the afternoons and just like watch him, like he'd do these paintings from scratch. It was great. So I think you should do that. If you're going to do it that way. It'll have a lot of flair.
Right.
Happy trees.
Oh, God. No. No, I couldn't bring myself. Couldn't bear.
Oh, come on. Oh, well. Maybe I'll have to do
Not
it.
to worry. Yep.
Well, before we go, let's mention Carl's documentary real quick. I think that's coming out soon, right?
Carl's doco, yes, the Australian electronics documentary, which we mentioned last time. It was originally supposed to be just a single doco, but he's interviewing so many darn people now, getting so much valuable historical information that he's going to turn it into a 3-part doco, which basically spans time frames. Here, that's what he's thinking, early time frames and then up to 1980s and then 1980s onwards. So, and how things have changed, how the Australian electronics is still Australian specific kind of thing, but it has parallels all over the world. So, it's just going to be so awesome.
Because I only have limited experience in naming like you and John Oxer and John Boxell from Tronic stuff and, just online stuff.
John Oxer's in it, actually. He's in the doco.
Yeah, I saw that. Yeah.
So
that's great. That's really great.
And, it's going to be fantastic. He's got so much material. He could release a 6-DVD box set of, this thing. Seriously.
And one person would buy it.
Well, no, I reckon he'd sell hundreds of them, actually. I think it'd be quite popular. But
I just meant that
anyway,
much length. That's a lot of length.
That's a lot of geek watching,
Yeah.
Anyway, so that's and he's hoping to release another trailer shortly, so that will go up on my site as per usual.
Great.
As yet another teaser. So it just he just keeps finding people because he talks to someone and they go, oh, you should really talk to this guy, and then he goes and he's flying all around the damn country interviewing people,
That's great. That's awesome.
That's fantastic. So, and there may, no, I won't talk about it, but we're thinking about an official premiere and all that sort of stuff as well.
Oh, cool. That red carpet.
Cool. Well, if we can maybe get something like that happen. Yeah, here comes Dick Smith and here comes Dave Jones and
you should
here comes Leo Simpson.
If you guys need me to announce on the red carpet, I'm willing to fly out there. So
okay, you
just
can
pay for my ticket and my lodging and my food and my entertainment costs.
Cool.
Yeah. All right.
All right. Well, that's enough for the amp hour.
Yeah.
Yep. I don't think we got through half the stuff we had on the list. Actually, we had a lot more cool stuff on there. So
push
carry
it to next
over.
week. Yep.
Great.
Great.
It's been a good one.
All right.
Thanks for joining us.
Bye-bye.